is a task that I need to do. It is to implement observability. Have you heard about this terminology before, observability?
No, I haven't.
It's the ability to see what is happening in the application itself in production. Do you know what this means in this context in production?
See what is happening in the application itself in production.
You may guess. No
oh, yeah, I'll take a guess at it. So it sounds like how the parts and the pieces fit together as it's being coded. Is that it?
Not like that. I will give the answer.
Okay.
For example, have you noticed that a couple of weeks ago, Cloudflare, which is a major internet provider, went down? Have you heard about it?
Oh, no, I didn't, but I did have some trouble with a few applications.
Probably due to that, because Cloudflare is in the front of so many applications. And because it was down, for example, ChatGPT was not available to log in, either to use. So it was down. The fact that it was down and there was a trouble happening for the end customer, which is you and I and hundreds of millions of people around the world, that fact is what I mean by in production. Because the end customer is using the feature or is being affected by some mistakes or some error or something else.
Oh, I see. It's what's being produced by the program.
Yes, and also in production means it's in the hands of the end customer.
I see. Oh, that makes sense now. Yeah.
So it's a very common term that we use as developers, because usually we have three environments. One of them is in production or just production. In other words, it's the product in the hand of the end customer. For example, this stuff that we are using right now is called StreamYard. It's a product from a company, and we are using it right now. So this version that we are using right now is in production.
Oh, I see.
You and I and other people around the world can use it. It's in production. The other environment, it's called, sometimes there's different names, but it's called mostly UAT, which stands for User Acceptance Test. Also called homologation.
What's it called?
Let me check the spelling, because I forgot how to say it properly.
Oh, that's all right. I imagine you said it right.
Let me see if I'm not just pretending that this word exists. Homologation. Does this word make sense to you?
Did you write it down? Let me have a look at it.
Let me check. I will put in your LinkedIn.
Oh, message. There it is. Homologation.
Yes. Does it make sense to you?
Official.
Because I forgot how to say it properly, but in other words, is a testing environment.
Oh, I see.
So it's not ready yet to go to production.
Oh, I see.
It's still being quality assured. So there is specific professionals called QAs, QA, quality assurance.
Oh, yes, I'm familiar with that.
They are they work alongside us developers to ensure the quality of the service or the
A bug
application.
test.
Exactly. And also they test the features to see if they are doing what they are supposed to do. So sometimes the application may not have any bugs, but it's not doing what it was supposed to do. So they will also check that compliance. They will make compliance checks to see if things are working as expected.
Oh, I see.
Without bugs. This is the second environment. So we talked about production, UAT, or testing environment. There is another one which is called, most of the time, just a developer environment. Developer environment may be our own machine, our own computer. For example, you have installed IntelliJ in your computer.
Oh, yes.
So it may also be called local host. Local host, another name. But sometimes it's a separated environment specifically for developers to do their stuff without relying 100% on their own machine, on their own local host.
Mm-hmm.
So right now, my task is to create observability in production, which means I need to be able to see if the application is working fine in production, is not down, is not unavailable. And I also need to have visibility on which specific codes are being searched by the end customers. So
inserted, I think. Is that right?
Could you repeat?
Oh, I think you mentioned you wanted me to correct you, so I just want to say, did you mean to say inserted by the end customer?
Searched.
Oh, insertion.
Searched.
Oh, searching. Wait, hold on. I want to put my headphones on. I have this on my laptop. It might be a little hard to hear for me. Sorry about that.
Okay, no problem. But I tried to spell this word here. Searched.
Oh, searched. Oh, I see. Searched by the end user.
Yes.
Oh, I see.
I will share my screen. It's going to be clear if you see it.
All right.
Okay, can you see my screen?
Yeah.
Okay, so I will access the website. So it's like that. It's in Portuguese.
Oh, this is the website that I cloned from GitHub.
Yes. It's real. There is a front end, which is this thing that you are seeing. And there is also a back end, which is not visible, but it's also ready to respond. For example, when I try to search by a code here, ABC. Let's see. Okay. There is one result for a code. Here is called code in English. It's just a example. I don't know if this is a real item, but it's here. When I have searched ABC, right now I don't have visibility to say for you or for anyone else how many times per day this specific code is searched upon. I don't have this ability to say to you it's rarely searched or it's very often searched. I don't know. I just don't know. I don't have observability about this.
Oh, I see.
That's not a problem, but it's a missing feature. When someone asks or search for a specific code, I want to be able to tell my customer or whoever wants to have this information, these codes are highly searched daily. Or the other way around, these codes are not searched at all, or very rarely.
Oh yeah, you could say they're not frequently searched.
Yes, it's better. It's better to say like that. Thank you. They are
Sure.
not so frequently searched. Exactly. So I need to have this capability in this application to be sure which one of these codes are more frequently searched or not. So this that we are talking here is observability. It's one aspect of it. How can we do that? I have already done some homework and created a specific dashboard for this. But it's not ready yet.
Oh, okay. So would
It's
you
just a skeleton.
Would it be like you take the user input, and if it matches an entry in the database, then you increase a counter by 1 associated with that hash map?
Exactly. This way that you mentioned is the direct way. But nowadays we have some tools that do this for us. So we don't have to deal with the complexity of managing this scenario. One of these tools are called Grafana. So here is an example that what we can get. For example, we can read memory and CPU consumption from the backend perspective, number of logins, another memory and CPU maybe for the other backend or for the front end.
Is this an API? Is that what it'd be called?
It consumes an API. Consumes an API to be able to get this information. And if we look at the raw data, it's just going to be API calls. But API calls by themselves are just text. So they are not beautiful. They are not really useful for the end customer to look at them. That's why we try to beautify the data using Grafana.
That makes sense.
Because these colors and lines and bars and so on, it's easier to digest for a human. It's easier to make sense of this.
Yeah, I understand.
But in the background, is like you said, it's only API calls. It's only text.
So it's called an API call when you're asking for the data that's been stored.
Yes, I will teach you the difference between API and a website, for example. I think it's going to be useful to have this distinction. Tell me a website, any website that comes in mind.
First one that comes to mind is just Google. I guess IGN. How about that one?
IGN. Okay. So there's a bunch of stuff happening right now. There is the website's loading, and we can check if we type F12, we can inspect the calls that are being done in the background. There's a bunch of them. Later on, I can teach you how to read and understand all this stuff. But For now, let's just say it's a website. It's a simple website. It has colors, images, photos, formatting or text format. There is some kinds of different typefaces. I don't know why it's because I am in Brazil. Let's change to English. Okay.
Yes.
So it's just in English, but it's the same website. So we have colors, structure. We have a certain way of making the user experience easy for the end customer. There is a side menu here. We can click on stuff. So there is also action happening. If I click here, something changes. If I click here, something changes again. This is a typical website that we are used to. And about the APIs. The APIs, they are just text. I will use as an example the Poke API from Pokemon. If I click here, submit, it's going to, never mind this. Oh, it's here. It's already here. I will click here. Okay, that's it. This is an API.
Oh, wow.
More specifically, a RESTful API or HTTP REST API. It's just not random, it's just text. See, there is no way that I can click on things to change the behavior. There is no color, there is no image, there is no photos. Very different from this one, right?
Yeah.
Backends, front ends, mobile applications, even games, TVs. For example, if you use a smart TV, it also consumes or generates APIs calls like that. This is the lingua franca of the computer world nowadays. So most of the service that we use nowadays relies on these things, just text like that. And if we apply a Beautify plugin, they will look like this. So it's the same text, but it's structure for humans to be able to more easily read them. So I just applied some beautification, but it's the same data.
Oh, I see.
And it's called JSON. That's how it's called, JSON.
Oh, yeah. I've heard of that. So it's not HTML.
No, exactly. That's exactly the point that I was trying to make. This is HTML with CSS and JavaScript.
Oh, I see.
It's a trinity. HTML, CSS, JavaScript. They all work together, so we can have this experience of a typical website nowadays. This anime is really interesting.
Oh, yeah.
I really like anime.
Oh, yeah, me too. I didn't realize that. I don't think we talked about that.
We can talk about this a lot because I love anime.
What's your favorite one? I'm just curious.
Dragon Ball Z.
Oh, okay, nice. Did you ever see Outlaw Star?
What? Could you repeat?
It was called Outlaw Star. Let me see. I can write it in the little chat over here.
Outlaw Star.
Oh wait, I can't join the chat. How do I join the chat? Let me see. Join the chat.
You can send me on LinkedIn, no problem.
Oh yeah, here's Outlaw Star. It's a little bit like Cowboy Bebop. but
Cowboy Bebop, I know really well. Oh, this one I don't know yet. Outlaw Star.
That's a great show. I really like that one.
Good to know. I will watch it.
Okay.
Let me
Cool.
just put here in the whip. I have a folder here for things that I need to do, or I need to do. Means work in progress. Seems like from the 90s.
Yeah.
Yeah,
it was sort of a classic on there was this channel that was called Toonami. So Cartoon Network late at night would show anime, and this was one of their early anime that they showed along with Cowboy Bebop and Dragon Ball Z and other stuff like that. And it was great. I remember the first time I saw it, I was just like totally blown away.
I will watch it definitely. I really like when someone refers some TV show to me.
Awesome.
There is also a classic one. I don't know if you know this.
Oh yeah, Trigun. Trigun's great.
Yeah, really good.
I like that show a lot.
And yeah, there's this. So see, when I have clicked, something happened. A new page showed up, and there is some video here. Everything that you just saw happening, there is also a JSON behind the scenes.
Oh, okay.
So even though we can do this in basic HTML, in CSS, in pure or vanilla JavaScript, nowadays, most commonly, we are also relying on JSONs. For reasons that I will tell you bit by bit, because there is a lot of reasons to use a JSON. But I can tell right now one of the reasons. It's easier to change the JSON without needing to change the front end. That's the main reason nowadays.
And why? When would you want to change the JSON?
Good question. For example, I will use some Android Play Store. We have the Play Store and also the App Store for Apple. Let's suppose, let's check TikTok, for example. I don't use TikTok, but it's very famous. Let's use it as an example. If there is a bug, or if there is a wrongly displayed data in the app, or a color that's not quite right, almost anything in the app itself, APK itself, if the developer needs to fix this, they are going to need to release a new version of the application and promote it to the App Store or the Play Store, and hope for the end customer to update the app, because they have no means to force the updating of the app. So most people are still gonna see the outdated version with the bugs, even though there is a new version available for them to update, but they don't care about it. They won't update. Most people don't update things.
Oh, yeah.
I personally like to have the application updated, but most people don't do that. They just use what is there, and that's it. If it's updated or not, they don't care. They just care about swiping up the videos. So if the fixes are coming from the back end, regardless of the application being updated or not in the smartphone of the end customer, because the fix is in the back end, they can just promote the fix for production, in other words, for the end customers, and they will get the fixes regardless of the status of the updating process of the application in their respective smartphones. So why I'm talking about the backend? Because the backend is the main guy that generates the JSONs. So when the JSONs are right, the end customer will also get the data right, regardless of if they have updated the Android or iOS application or not. The same happens for websites. Sometimes this website is cached in the browser, and they may not update the website fast enough, so people will get the outdated experience during the navigation. If the HTML is the main engine behind things, but when the JSON is the main engine behind the data, regardless of the state of the browser that the end customer has, they are going to get the correct or updated data because it's coming from the JSON, aka the backend. I know it's not so easy to understand. It's a somewhat advanced thing, but just for you to know that JSONs are the main thing nowadays. Most of the time we are dealing with JSON.
Okay.
About the Grafana stuff that I was talking, it's also JSON data. So all these metrics here are JSON. And Grafana reads the JSON and turns then into this viewable or understandable stuff.
Oh, I see.
For the application that I'm managing, right now we have some.
So can I ask a quick question?
Yes.
So would you say that JSON just helps you to manage the elements that are in the code? So all of the things that are essentially objects of the code go into JSON, so you can just work with them without all of the structure of the code.
Mm-hmm. Exactly.
Oh, okay.
The data itself, and also the behavior. For example, we have an example of behavior here.
Right.
It's a Boolean.
It's not hidden.
Yes. Let's suppose we are going to use this Poke API to create a Pokemon game. We don't care about the specific details for each and every Pokemon in existence. We don't want to have to deal with it directly. So we make use of this Poke API to abstract that complexity of managing all the available Pokemons. We abstract that to the Poke API. So we only care about the game itself, not about the details of each Pokemon. And here, for example, we have the ability. This is a list. That's why it's in plural. And there is a bunch of abilities for this Pokemon. It's called Ditto.
Oh, I see.
And there is this one and also this other one. And that's it, 2 abilities. This is the second, and this is the first ability. And somehow The first one is showing up. I don't know what that means. We may decide to create something specific because of this property. Is hidden false or is hidden true? We may decide to make use of this. For example, the Pokemon needs to get to level 10, and then the is hidden ability become from true, from false to true.
Oh, yeah. Or would it go from true to false, I guess?
Or the other way around, if the Pokemon is not yet on level 10. So that's
it's hiding the ability imposter until it hits a certain level, I think.
Exactly. Oh, right. Because I understood incorrectly here. So is hidden false, so it's showing up. Is hidden true, so it's not showing up. Correct. You got it right. So we may decide to use this in this way. Or we just may decide, no, I don't care about it's hidden.
That's interesting. It does make it a lot more accessible to just look at the elements of the program in a way that's more readable. I see why people use that.
It's like English, for example. English is considered a world language. So
yeah,
even Chinese people learn English. Some of them, but there are a lot. Because it's like Latin was in the past. So it's a lingua franca.
Yeah.
It's a common language between nations. In the backend, regardless of the technology, either it be Java, JavaScript, PHP, C#, any language, or specifically any modern programming language, all of them it can easily read and understand JSON. And it also readable by humans.
Yeah.
Two advantages. Easily readable by computer programming languages, and also easily readable by humans. That's why it's so popular. And we have lots of other stuff here. We may decide to use it or not. But for example, there is a mention for the games that feature Jita as a playable character. So there is this game, this one, and also this, I don't know. Yeah, I didn't play. I only played Emerald. This other one I didn't play. But it looks like it's a very common Pokemon. But yeah, this one, I have played this one. So we have a bunch of data available about Pokemons here in this Pokemon API. And we may use this for something like a game, like a Wikipedia, like dedicated to Pokemons and so on and so forth. Here's an example of a behavior changing based on the value. So at the left, we have the key, and in the right, we have the value, like a dictionary. There is also some images. Let's search for .png, for example. Well, there is an image here. Let's try to access this and see if it's really it's really something that we can use as I forgot how to say, but as a way to draw the actual character.
Oh, I see. As a model.
So, as a model, good. So here we have the image being used, being defined, and we can also use this URL to draw a website. So, for example, this thumbnail here, probably in the JSON, is just a URL. and the HTML receives the URL from the JSON and renders or plots its real content as this.
Oh, interesting. Oh, okay. So it works like a database for the HTML to access.
Exactly. Because the website, most of the time, it's not good for it to be able to read directly any database. Few exceptions for local database in the browser itself, but in most of the times, it's not a good idea. It's a security problem.
It's probably more compact this way too, so it probably runs better.
Exactly like that. Because even though it's just text, it has a weight in the traffic. Let's see. For example, I will try to save this JSON locally, and we are going to inspect its size. So 24 kilobytes. Oh, it's not too much, but imagine that it may happen hundreds of times per day, or depending on the website, millions of times per day.
Yeah.
So it may be huge. If I was trying to get the entire JSON, the entire database, it was not going to be easy to do in traffic, even for nowadays standards. But with JSON, we got more compact data, more specific, more nailed down to what we need. That's another reason to use JSON. I know that's a lot of information, but it's all going to fit together later on. Let's check. Okay.
It basically works like an intermediary,
Exactly.
both for HTML, for people, and for the code itself.
Exactly like that. In our case, for the metrics, metric is just another name for what I just mentioned earlier. So I need to know how many times this code is searched per day. It's called metrics.
Yeah.
There is a specific tool that do that for us. Let me check, for example, metrics. So I'm using IntelliJ.
You're in Windows. Oh, yes, I recognize IntelliJ.
Yes, I'm in Windows. You may use Windows, Mac OS, or Linux. No problem. I usually, in the beginning, I suggest for the students to use Linux because it's more frequently used by developers, including the tools that we rely on. For example, Docker. Docker is Linux.
Yeah.
So all these commands here comes from Linux. If you understand Linux, you also understand Docker easily because it's the same thing. But if you only understand Windows, it has nothing to do with Linux or Docker. So it's going to be harder to understand what's happening in this code here. So in the first year, I suggest to use Linux just to be comfortable with it. But later on, you can stick with what you prefer, either it be Windows, Linux, or Mac, because you are already going to be comfortable regardless of the operational system. So it's just a matter of preference. It becomes just a matter of preference. But in the beginning, if the person doesn't understand Linux, it's advisable to try to use it because it's going to be really helpful in the mid and long term. And about the metrics, here I have some of them. A student of mine created Oh, okay, I created the base, but then he extended. Let's check where it's being used. Okay, here, for example, item service. I'm calling. I will increase the zoom. I'm calling the increment request function.
Oh, was that all? Oh no, it's not JSON, and that's or is that? That doesn't quite look like.
Doesn't look like Java, right?
Yeah.
It's called Kotlin.
Oh, Kotlin. Oh, okay.
Yes, it's a better Java.
Ah, interesting. It's like more
It's like,
simplified.
yes, exactly.
Is it for HTML basically? It's for using with websites.
It may be, but it's very flexible. You can use it to create even mobile applications, backends, and websites, even iOS applications and Android. So it's very flexible, and it's
Oh, interesting.
very user-friendly and modern. I haven't thought too much about it with you because usually it's good to know Java before going to Kotlin.
That makes sense. It's like is Java the foundation of Kotlin? Is Kotlin
Yes,
based on Java?
yes,
Okay.
exactly.
I like Java a lot, by the way. I think it's very interesting to code in. The logic is you state things very explicitly, I think. And I think that helps with like learning the fundamentals of coding for me.
Yes, it's good to get Java first because all other languages after Java are gonna become so easy for you.
That makes sense, yeah.
But the other way around doesn't happen. If you pick a easy language and you try to understand a hard language, it's not going to be a good experience. But
Oh, yeah.
when you get something hard first and then the easy one later, you get both of them.
Well, it's funny because I can't even say exactly, at least as far as I've gone, like what is so difficult about Java because I'm just learning all of its conventions and it all makes sense. Uh, but I can imagine after doing it, I'd read a different coding language and go, "Oh wow, this makes it so much more streamlined and simple." But
Yes, people
but I
usually
actually
say it to JavaScript.
I like it quite a lot.
I also like it because it pays the bills, it makes sense, it's well thought most of the times, and it's very stable. So 30 plus years it's in the making. So and it's also being used by billions of projects. So it's not something that was born yesterday. It's
Oh
very
yeah.
stable. And yeah, that's it. It's not the best of the best because I don't think it exists at all, but
A lot of
it's
people
worth learning.
seem to like Python from what I can tell.
Yes, and most of the time they are going to be data science or data engineers or known programmers because it's really easy to understand. But Kotlin is also based, at least in the syntax, it has learned a lot from Python.
Hmm.
So Kotlin, they have a presentation called "Standing on the Shoulders of Giants," which is my life motto as well. So uh, there they mention that Kotlin is based on the best things that other language has to offer, and one of them is Python, with, with its easy to understand syntax. So there's lots of influence from Python in Kotlin.
Oh, I see.
And about the metrics, there is one happening here. So what's happening? Fun is a abbreviation for function or method. And there is a body. So the body of this function is here in blue. And there is the name of the function, which is get all items. Never mind the parameters for now. There's page and size. Let's not deal with that right now. The important thing here is if I call somehow this get all items method or function, it's going to execute this body. And one of the things happening inside this body is the metrics incrementation for the endpoint get all and the method get. And there was supposed to have a name here for these metrics. Let's check where it's okay, labels. Okay, it will use the endpoint as a label. It will make sense in a few minutes, but it's happening here. So next step is to verify if this metrics incrementation is really happening. How can we know that? If we go to the Grafana dashboard, there's going to be a specific HTTP request. It's searched by product. Right now, there is no data. When I call this function, it's supposed to have at least one occurrence here. Because I just call it, it will create the first iteration, the first number from 0 to 1. And 1 is going to have to show up here. If this doesn't happen, it's because there's something wrong. Because it was supposed to show up here. The details on how it's going to come from this from there to here. For now, let's leave it like that because there's a bunch of tools doing this stuff in the background. But superficially, that's what's supposed to happen.
Oh, so you need to find out why it's not doing that, I guess, later.
Exactly.
I see.
It's called debugging. So
yes.
Debugging most of the time is trying to understand what's happening. That's it. Because unfortunately, this is not an exact science. So it's not like mathematics. It's a very common misconception from most people. They think programmers are good at math. They are not.
I think that's interesting because so many of the logical fundamentals of programming are in the understanding of the relationship between numbers. You know, like if you want to talk about matrices, for example, I had to do a little coding exercise the other day where you find a progressing matrix going from the top left to the bottom right, like an array. So it's like, I can't remember how to describe it. I'm describing it very badly, but you could find an intersecting array coming from the top right to the bottom left. And to know that one, you have to know the entire full length of the array. Maybe you know what I'm talking about. And so it's like, once you know the full length of the array, then you can figure out where those two lines would meet and where the second one would start. But it comes from knowing the relationship between lines. And so I think that's where a lot of like logic is that you end up working with for algorithms. And that's very fascinating to me.
in these exercises, typically, they will showcase some logic and mathematical concepts. And the language, it is flexible enough to give this exercise life with the language itself. And for example, I can do a mathematical calculation here explicitly. It's possible. But look, in this entire service item service class, there is no mention to any mathematics explicitly, only implicitly. Does it make sense? Let me check if I...
Oh, yes, implicit and explicit, yeah.
Exactly. So most of the time we are dealing with math and logic implicitly. And for example, here, there is mathematics happening in the background here, but
you're not thinking about how to code it exactly at this point.
Exactly. That's called abstraction.
Oh, interesting. So which aspect of that is called abstraction? Oh, the code that's here is the abstracted code.
Yes, exactly.
Oh, I see.
All abstractions. Because in the past, a couple of decades ago, we needed really to get the assembly code right in order to make things happen as we wanted to in the code. That was assembly or Fortran, for example. We need to add X, load Y, and that was the language, the programming language. Add X, load Y, sum Z, and it was really complicated. Really complicated.
You had to do everything explicitly, basically.
Exactly, in the past. Nowadays, it's the opposite. That's why we don't use explicitly mathematics anymore, most of the time.
Oh, you're using libraries a lot more.
Exactly. For example, metrics. If I click here on item metrics, I will go to this class, item metrics service.
Oh, that's very convenient the way you can jump like that.
It's good. You click on Control, and while holding Control, you click on.
It goes to the function. That's great.
And there is another shortcut that I'm going to show you later on, but it's very used, this combination here. And if I keep digging, if I keep going on, I will arrive, for example, here, meter registry.java. I didn't have created it. I hadn't created this stuff here. We can even know who created this. So that these smart guys, they created this stuff. I'm just using it. I don't know the details. Most of the time, I wouldn't even be required to know what's happening here. That's also an example of abstraction. I just trust that these guys know what they are doing, and they have created this registry for me, and I will just use it.
You just need to know its function and know that it does what you want it to do.
Exactly. Another example of abstraction. For example, a sorting algorithm. It's a classic bubble sort, for example. There is one specific called bubble sort. It's very often asked in interviews. And there is a way to do it manually. We can code this in any language, any programming language. But most of the time, we are going to do something like that. Just an example. as list. Let me create something here. Vol list. List of strings or numbers. Okay, and let's try to add something. Okay, I will leave it empty for now. I was just trying to show you this function here, sorted by. This sorted by, it abstracts everything that we need in order to sort an array or a list. So we don't need to manually create an algorithm to sort a list in any way, shape, or form, because there is already a function that does that for us. It's called sorted by.
Right. And how what's the logic behind how it sorts? What does it sort your array into?
Good question. I don't know. Let's check. Return is a little. Oh, we also get the documentation. Most of the time, if it's a well-established function, it's going to have a really good documentation.
Oh, yeah.
But sometimes that's not the case, but most of the time it's going to be like that. So returns a list of all elements sorted according to natural sort order of the value returned by a specific selector function. This sort is stable. It means that elements for which selector return equal values preserve their order relative to each other after sorting. It doesn't mention which algorithm it's using, but we can try to dig deeper. Okay, let's try this sorted with.
It almost sounds like it needs another kind of function or input to tell it how to sort.
This is called composition.
Oh, okay.
You arrived at a new programming good principle or good practice.
I see.
So composition. Very infrequently. Does this word exist?
Infrequently.
Infrequently. I always got it incorrect.
Okay.
It's very rare to create something from scratch. Usually, you are going to take something that's closer enough to what you want and just extend upon it.
That makes sense. And so composition is when you have two functions working together or more?
Yes.
Oh, okay.
They are closely related to what you want to do. Sometimes you just need to change them a little bit. So instead of creating, let's say, 100 lines of code, and then adding one line of code that's going to do what you need to do, becoming 101 lines of code, you just make use of one function that already does what the 100 line of code was supposed to do, and you just add a new line that's the specific thing that you want in the new behavior. So we will make use of what already exists.
That makes sense.
If we go deeper and deeper, we are going to see that these functions, they are compositions of other functions. See, apply, to type array, to list. So it's happening in this situation. It's very common. Another composition here, composition, and inside composition, another composition. So there is one here and another one. If we keep digging, they will keep happening until we arrive at something called primitives.
Oh, that's what that means. Oh, interesting. That's the code that doesn't refer to anything else. It's just the base code that gets referred to.
Exactly. It's the ontology. It's the building blocks that doesn't
Wow.
that are not built by anything else.
That's interesting. Yeah.
So method physics. Okay. Calls in place, and we can keep digging. Since I don't really know all the details, it's not supposed to be something that we need to know in order to be productive in the language. But it's available if you want to. You can keep clicking on that while holding Control, and you are going to find the primitives and other interesting stuff. Most of the time, you don't need to know the details because the abstractions, they exist to prevent or to allow you to not need the details. A hardware example for us. We use mouse or mouse pads and keyboards. We are using the internet right now. I don't know the details about how my Bluetooth mouse talks with my laptop. I don't know. It's magic. It's fairy dust. But it's happening anyways. I'm using my mouse here. It's Bluetooth. It's communicating with my laptop wirelessly. I don't know the details on how this happens, but it's happening anyways. That's another example of abstraction. Makes sense?
Yeah, that makes sense. It's not important to know how it works, just you need to know it's a tool that you can apply a certain way.
Yes,
and you need
if you want to know,
to.
if you want to know, it's possible, but most of the times you don't need to. I sometimes I try to know. I go deep in the rabbit hole.
The rabbit hole, yeah.
Yes, I find this expression really funny because in Portuguese there is a sexual connotation to this.
I can imagine that. That sort of exists in English too. There's other ways of saying that. What is it? I don't know. I don't know if it would be appropriate for the stream, but I'm curious. What is it in Portuguese?
It's because I don't know in English, but in Portuguese, most of things can have a sexual connotation.
Oh, I was just wondering how to say it. I like the sound of things in Portuguese. I wanted to try to say it.
You want to say it in Portuguese? Pode ser assim, ó. Buraco do coelho.
Oh, I couldn't quite. Wait, how do you say it?
Buraco.
Buraco.
Isso.
Oh.
Yes.
Oh, buraco de coelho.
Yes.
How do you say rabbit? How is that said? Coelho?
Yes.
How did you say it?
Coelho.
Coelho. Oh, okay. I didn't realize Paulo Coelho's name is Rabbit.
Yes, it's Paul Rabbit.
Oh, Paul Rabbit. Interesting. Oh, how funny. That's very, it's like Aesop's Fables kind of a name. Paul Rabbit, like, went to the store, to get some carrots.
Have you read The Alchemist?
I have read The Alchemist. I also read he had this book called 11 Minutes too that was interesting as well. I
didn't read this one yet. I really liked this book. I read it when I was a teenager. It created a huge impact on my thinking.
I liked it as well. I thought it was a good book too.
Good. So, and this word here, buraco, also can mean
buraco. Yeah, I figured. Buraco. Thanks. Sorry to bring down the quality of the stream. That's funny.
No problem. And
So it's good to learn some new languages or learn some new words.
Yes, I agree. So if you want to, you can go this path and learn a lot of things, but they may not be useful for the short term, but may be useful in other ways. That's why I give myself permission to sometimes study or read something that doesn't really has anything to do with my work. It's really good to do that. I just try to remember that I need to know what I need to know in order to survive in this planet. So I need to remember myself all the time that I must not lose myself in random studies. I need to
So,
focus on something.
so in coding, would you say you work more with abstractions than with precise, than with, what was the fundamentals, I guess?
Yes.
How did you call it?
Primitives or fundamentals. Exactly. Most of the time we deal with abstractions. Like you are seeing exactly here, for example, all these things are abstractions.
Because the supposition is that the primitives work. Somebody else figured that out, so you don't need to think about it.
Exactly. A strong example. We can create a library dedicated to security of the application. So a cracker doesn't steal our data or our code, our customers' data, and so on. So we can create a library dedicated to security. But it's the worst idea possible because it's probably not going to work. It's going to be vulnerable, and crackers are going to exploit the application because
you have to have the algorithm that
and data and real world scenarios, and it's very complex. So most of the time we trust the dedicated libraries, security libraries, when we need to make things secure.
Well, that's them. Oh yeah, like that's where math would become really important in coding.
Yes, in the lower levels, in the details. And another important thing for you to know, we as developers, are different from library developers.
Yeah. So that's interesting. It's almost like since you'd be working with abstractions more, it's a lot like working with HTML instead of working with the fundamental code that makes up HTML.
Exactly.
And there are conventions of language rather than conventions of programming itself, where when you're working with conventions of programming, you'd be iterating through arrays or something like that. But here it's more like you're working with conventions of how to approach certain problems, like what tool to apply to what job. So you just have to be able to recognize the job and the tool.
Exactly. We are most likely this than library developers because they need to create something that are probably going to be used by hundreds or thousands of developers.
Wow. Yeah, that's very cool. That's very appealing to me. Just make something like very well coded and does a job.
Exactly. For example, Kotlin. Kotlin is a valid example. Spring is also a valid example of library development because Spring is a framework. For example, here we have this annotation called @service. If we click on it, you are going to read a familiar name here.
Yes, Spring.
So it came from employees or developers from a company called Pivotal, which is the holding of the Spring framework. So they created this package with this specific name because it was created there from Spring framework specifically, and more broadly from Spring team, and more broadly from a company called Pivotal, and nowadays it's called VMware.
Oh, so I think I've heard of that.
It's the name of the company that owns Spring itself.
Mm.
And the specific guy that created this, his name is here. Jürgen Holler. I don't know how to pronounce his name.
Yeah.
He is a framework or library developer. So he needs to really care about the details, the specificities of the language, of the platform, and so many things. He is very different from me and from you and from most developers.
Mm-hmm.
His focus is different.
I see.
Our focus is on the abstractions, the right tool for the right job, and that's it. Okay, hope this is making some sense, because it's a somewhat advanced topics, but I try to show while we do things.
Oh yeah, this makes a lot of sense. I really appreciate seeing the fundamentals of how you do the job, and understanding the difference between this and, like, if you're working with code, if you're working with the fundamentals of coding, it's a lot about logic. It's about how you logically structure things. And it seems like this is more about understanding the task that you want to accomplish and the utility. And it helps a lot to see, oh, it's like, okay, so I'm putting together tools. I need to know what needs to get done and what tools to use to do it.
Exactly. And if you go to the job market, if you go to the job market only with the knowledge of how to do things in the abstraction level, it's enough. Most of the time, it's enough.
Wow. That's fascinating. I would have had no idea that.
Most people get this wrong. They keep stuck, for example, 5 years at a computer science, trying to get a computer science degree, and trying to understand basic things, basic meaning fundamental, and structure, logic, algorithms, data structures, and so much stuff that when they come to the job, they will ask, for example, create a unit test for this, and their word will fall down, because it has nothing to do with what they learn.
Oh, I see. And
science.
Yeah, I don't know if there's a short answer to this, but how do you create a unit test for that?
It's very hard to do that. It's one of the most difficult things, because it's too much to explain right now, but it's really difficult. Unit testing and also integration testing, it's really difficult to do. Let me see if I have one example. I have created some of them. So I have some of them here, but don't trust this, because it's most likely it's not going to be like that in most scenarios in companies. Integration testing, unit code or unit testing, it's a nightmare. It's a nightmare. And it's a requirement, unfortunately, because they will ask us to do this, and probably you are going to take 1 hour to create some function, most likely, and 8 hours to get the test correct.
Oh, geez. Well, so what does
times more.
what does the test do exactly? Oh, okay. So it's saying it needs to return a paginated list of the items. So you would be making sure that it actually does that.
Exactly. It's
Oh,
easy to, superficially, it's easy to explain. I will explain it briefly. Do you know the concept of the compiler?
yeah. The JDK or the Java JVM.
The JVM, yes, it takes part on the compiling, but basically the compiler is a specifically designed program that turns
Oh, that
this.
into computer code, basically.
Exactly. So the compiler, its mission is to turn this high-level language, because it's human readable. Nevertheless, it's not readable by all humans, but it's human readable.
Right.
It turns into machine code, which can be human readable, but its purpose is not to be human readable at all. It's only to be machine readable. The compiler is binary, exactly. Compiler does that. And it prevents bugs. It prevents inconsistencies. It prevents, let's say, grammar mistakes. It prevents typos. It prevents orthography mistakes. For example, if I try to do this, it turns red. It's already complaining. Just because I get rid of one letter, it started complaining. It's an example of a compiler doing its job. It's preventing me to go ahead with a mistake.
Because it recognizes that it doesn't either know that command or there isn't an object stored in its code.
Exactly.
Or a class, I guess.
Also, all these reasons. For example, I will do it again for this val keyword. I know that it is a keyword because it's in a different color. But eventually we memorize the keywords even without the color. But I have removed one letter, and now it's complaining. It doesn't know what to do.
It just means value, is that right?
Yes. But it must be written down exactly like that. If I try to write value, for example, it's also not correct. Because it expects to be exactly like that. And the compiler is complaining, and that's good, because it prevents bugs in production, inconsistencies, and lots of problems because of the compiler. But the compiler doesn't know how to deal with things that the developer wants to happen. It knows how to deal with things that the compiler itself and the creators of the language told the compiler, you need to check this and that.
It knows when something isn't in its language, essentially, like it isn't translating correctly to it.
Exactly. It's really good in this job. But when I need to create, for example, a paginated result for all items, the compiler doesn't know what it means. It only has meaning for me, the developer, as a human. So it's a requirement that I have arbitrarily created, so the compiler doesn't know about this. Then comes the unit testing or integration testing. It's a way of teaching the compiler about rules and requirements that it originally didn't know about.
Originally. Yeah,
Didn't know.
that's a tough one.
Yes. So does it make sense, this explanation? It's like teaching the compiler to do stuff and to verify things that it was originally not supposed to do.
You're saying that a class or a method teaches the compiler to do something that it didn't originally know how to do. Is that right?
If they are tests, unit tests, because a class by itself or a function by itself, they are not tests. But when you annotate them with this keyword here, they become tests.
Oh, okay. And so does the computer actually read the word test in a specific way, or is that for the coders?
Both.
Oh, what does it do with the word? What does it do with test? I'm having trouble understanding that.
It teaches the compiler that the following function is different from a normal function.
Oh.
So an example of normal function here.
Right.
Get all items. An example of a testing function. The name of the function is different, and there is also this specific notation.
And so what does it do differently with that function? Does it just treat it as something that exists on its own, separate from any body of code? Is that what it does?
When we got it right, yes. It's independent from the code itself, the real code.
Oh, so you use this testing to make sure that these functions can be called correctly. Is that what they're for?
Yes, and also that they do what they are supposed to do from the point of view of the developer, not from the point of view of the compiler.
Ah.
It's like an add-on to the compiler. It's another security layer, let's say it like that.
And so what is different about it from a piece of code that doesn't have test in front of it?
For example, if as I mentioned, if I try to make a silly mistake here, it won't go forward because the compiler is going to complain, and that's it. It's not going to generate the code.
Oh, I see.
This is the compiler perspective. But let's say that this page request here, it should start with 1 here. It's just an example. It doesn't make sense it may make sense. So it starts with 0, but it should have been starting with 1. But the developer forgot to put 1 here and put a 0. The compiler, he won't understand that it was supposed to start with 1 instead of 0. The compiler doesn't care about this because the compiler are only checking if the syntax and grammar is correct.
Right.
But there is another layer to that. It's not sufficient or it's not enough for the syntax or grammar of the programming language to be correct. It's also necessary for the behavior of the code or the application to also be correct. The unit tests asserts the second case.
Oh, that's interesting that it doesn't do a check to say, hey, this page doesn't exist or this object doesn't exist.
It may do. It's being done by this Elvis operator. We call it Elvis operator because it's like Elvis hair here.
Oh, I see.
So it's checking if page exists. If not, it's going to consider this number on the right side. But the issue is, let's suppose my manager in my company, somehow he wants to start paging from 1 onwards, not from 0. The compiler doesn't have any mean or any way to verify that, because it's something arbitrarily defined by my manager. That's why I need to create a unit test that makes sure if this segment here of code is starting from 1 instead of 0. So the unit test, it verifies or check or assert, for example, assert equals.
So
this start with 1.
Oh, so the unit test makes sure that the code that you have running actually works on the website. It checks all of the possible ways that it could go wrong and make sure that it doesn't.
Yes, and also the arbitrary requirements. Does this make sense? Arbitrary?
Yeah, arbitrary makes sense. And so what are the arbitrary requirements?
In this example, my manager just told me it needs to start from 1. Or it needs to start from 7, because I'm in a not so good day. So all pages should start from 7, because I have power to make you guys do this. So totally arbitrary, out of his head.
I see. Oh.
And we just need to make sure the code starts with 7. And when we create the unit tests for this, if a developer later on, let's suppose next month, he sees, oh, it's wrong, it should start with 0, I will change that. Then he goes ahead and change it back to 0, as God wants us to do. And the unit test will be broken because of that, because the unit testing is expecting it to start with 7. But somehow, someone changed it back to 0. The unit testing complained because of that, and then the developer will check the unit testing, and the unit testing is going to say it was expecting as 7, but it was a 0. That's incorrect.
Oh, so the unit testing is essentially a little program that you run on your program to check that its parameters match the parameters that have been described for the job that is what you want to accomplish. Oh, that's actually very interesting. So this is the sort of thing that should stop an error like that from occurring, of there being a page numbered 0, for example, that doesn't have any data on it and causes a problem.
Exactly. The test does that. It does that because the compiler can't do that for us, because the compiler doesn't care if it's a 0 or if it's a 7. It only cares if I'm spelling correctly the programming language.
That makes sense. That's very interesting. And so a big part of that, I imagine, is thinking about all of the different things that could go wrong, and defining ranges for stuff, for what is a correct range where things will be functioning correctly.
Exactly. For example, we can create a specific test that makes sure that the range for the page are always between 0 and 10. Not less than that, not more than that. You can also create a specific test for that. Let me see.
Oh, that's interesting.
Yeah, here, for example, I'm defining between 0 and 10. I could create another one that checks if the number is not negative, because it's not allowed to be negative. So if somehow other developer tries to put a negative number, it won't be able to do that because the testing is not going to allow this to happen. From the compiler perspective, -10 is totally valid because it's a real number.
Right. It's an integer.
From the business perspective, it's not allowed to have negative numbers. So I create a unit test that prevents this scenario from happening. So it's a complement to the compiler.
Yeah, that's interesting because to the compiler, it's just like, does this thing fit its data type? So it's like, yes, it does because it's an integer, and I know how to talk about integers. I can say the number, -10, even though that doesn't make sense in the real space of quantities of objects that can be displayed.
Perfect.
That's cool.
Like that. It's easier to explain, but when it comes to create this unit testing in the code that someone else have written.
Oh, it's like a huge pain.
Yes, it's really problematic.
Oh, that's funny.
It's the part of my job that I hate most.
I feel like I can understand that. I can just sort of imagine how that could get really sort of grating.
Yes. Fortunately, nowadays we have AI, and it can help us a lot in doing this stuff.
Oh,
in
yeah.
the past, we didn't have AI. It could take days to get unit testing or integration testing correct. And the difference between unit and integration, later on, I will explain. Because it's, there is some difference, but I don't think they are worth mentioning now. You already get the main concepts.
Yeah. Well, integration testing, I would just imagine, is to test that the various functions all work well together. Is it something like that?
Yeah. In this, most very similar to that. The main difference is that we test, for example, HTTP call. Let's suppose that this get all items makes a call to the API, poke API that I mentioned earlier. Let's suppose it makes a get request to the poke API. So it's an external thing happening. Because it is an external thing, I need to create some mocks so that I don't really depend on the external call, the real external call. I create a mock object to pretend that I'm making an external call.
Oh.
And that's an example of integration testing.
It simulates that external server, essentially, and the code that would be on it.
Exactly. We call this mocking.
Oh, interesting.
There's a mention to this here.
Well,
go ahead.
Oh, yeah. Well, how do you know what's on the other end of the code on the server? You can guess.
Another tricky part, because here in my code, because I have created most of this code with help from some students, but I also supervise it. And so I know what's happening here. So I can easily answer you what's external, what's integration, what's dependency, what's the system under test. But in code that we didn't write ourselves, it's really a nightmare to get this knowledge.
Oh, wow. And so you just have it as a placeholder.
Yeah, we need to figure out how many dependencies the service under test. We call it SUT, or SUT, which stands for service under test.
Oh.
So sometimes, or most of the times, the service under test has n dependencies. So we don't know how much dependencies.
Oh. And dependencies are the code that it depends on. It's the thing that it needs to refer to in order to run.
Exactly.
Ah.
And most of the times, it's not clear how many of them the code actually has. So it becomes really troublesome to mock.
Oh, wow.
Them.
Yeah, I can see that. Yeah, that's sort of an abstract task. Speaking of that word, to try and judge how much connection.
But unfortunately, we can abstract. So this is happening here. For example, the mock, this function here, it's doing the abstraction. So I don't really care what's the item repository about. I just need a mock or a simulated object of this. And the same happens for the items metrics service as well. And that's all good. But here we have only 2 dependencies. So only 2 mocks.
Oh, I see. So the items metrics service will be on the other server in the Poke API server, if it were that, essentially. Yes. And so will the item repository, like all of the abilities and stuff like that we looked at earlier.
Yes, but unfortunately, during the integration test, it's very common. For example, let's suppose item metrics service has 3 other dependencies by itself. And one of them has 5 other dependencies. So it's a dependency.
Oh, wow. Oh, geez. That's interesting.
Because if the code wasn't modular enough, we needed to mock the dependency of the dependency of the dependency.
That reminds me of how AI is structured. It's like a network of different, it's like maybe a neural network, they might call that.
Yes. It's very hard to debug because of that, and also very hard to code or to write testing code also because of that. So the explanation, it's satisfactory, but when it comes to actually creating the testing, it's a nightmare usually, unfortunately.
And what usually happens if you're not testing for all the right things? Like if you don't do it in Java, then if you put in a certain set of data, it'll crash. You'll get a program error. And is it like that with this as well, or is it like you just won't get a website, the page won't load correctly?
Exactly, it may happen. For example, let's suppose here in this, when I click this search button, it's what's being written down here, search, but in Portuguese. But it's just search here. Let's suppose I put something, just a number, and there is no such things. Oh, there is a one that starts with 7. Let me check. Oh, here. So it's just a random number, and it has, let's put it more wrongly. So a really huge number. If I don't write the testing code correctly, it may break the entire system.
Oh, I see.
So I need to prevent this by creating some specific testing scenarios that doesn't allow this to happen.
Oh, would that maybe have to do with the byte sizes and stuff like that?
exactly. Because we can check that there is a specific class, integer dot max value. It is
Oh, yeah.
a scientific code here. I don't know what's. Let's check because it's hexadecimal here.
Yeah.
Let's see if we can get the actual. Let's just do a quick conversion to decimal. So
wow.
that's the number. So, but as I mentioned, I have put a really huge number here. Let's double this. Rifle. So someone may try to use this in my system. If I don't properly prevent this from happening, it may break the call or even break the system.
Oh, it could cause an issue for the server itself, the system?
Yes.
Oh, wow, really? Jeez.
Yes. Not like it's going to go down because of this, but at least this specific API call is going to cause trouble. It may, for example, create I forgot the proper name, is overflow. I forgot. There is a specific term for this, but it's a overflow, integer overflow.
Oh, yeah.
There is also heap overflow. It's a problem. It may cause a problem. It may consume memory in a not so good way, and I'm going to need to free up this memory later on.
Oh, interesting.
So unit testing also prevent this. Nowadays, it can be prevented by the language itself and the compiler, but it's, as an example, it's good. It's good enough. So, an example of why we need testing. So some advanced topics here, no problem at all, because in my way of teaching students on how to program and how to be a programmer, I use this model. I call it pyramid model. So let's suppose there is intermediate knowledge and also advanced knowledge. Advanced, intermediate.
Oh, the stream seems to have frozen.
I'm back. Minha internet tinha caído. My internet connection was down. That's why we disappeared. But I think it's stable again. Check here. Andrew is going back. Hi, Andrew. Can you hear me?
That's insane. I was
Okay.
using my laptop earlier.
My internet connection was down, but no problem. We can keep where we left. So how far have you seen from my explanation about the pyramid?
Oh, I just saw that you said the advanced, the intermediate, and the basic, which I think you might have described this to me before, that you cover things from each part. Is that the idea? You can really jump into it, kind of at the deep
Yes,
end.
I don't care about the linear progression that most people try to make us think that's how it's supposed to be presented. So some topics, they try to convey to us that we need to know some basic stuff, then intermediate stuff, then advanced stuff. Yeah, they exist, but we don't really need to cover them in a linear way. We can just go ahead and try to understand what's in front of us. No problem. So I usually teach my students like that. So vertically. That's why
That makes sense.
I mix so many stuff. I
I
don't
think it
think my
gives
students are dumb.
I think it gives a lot of context, which is good because you have familiarity with things so that when you hear about them, it doesn't sound like it's just this free floating thing. And instead, like I've heard a lot of these terms before, like abstraction and, API and some of the other things that we've talked about. But when you showed me them in the code today, it's like, oh, okay, now I know that this is a tool that's used toward this objective, and that it's referencing these databases or other tools, and it's talking to these other tools on the or it's talking to these other things on this other server. And so it just gives me a sense of like, oh, that's what the job actually is. It's not using math and logic to try and build a function. It's about understanding the code. That's very important, and checking to make sure the ranges are acceptable for it, that it performs its use without going into any error categories, essentially. And it's like, oh, okay, now I understand a lot more about what it is that I'd actually want to be aware of and to try to understand.
Mm-hmm. Exactly. And with that, you are going to be well equipped with everything you need to start working ASAP. Because we don't take too much time covering the basics. For example, what is a data structure, algorithm, red, black, tree, the Dijkstra algorithm, and computer science stuff that you are not going to touch again in your entire life, probably. And then we start talking about intermediate stuff, and 5 years have already passed just to cover the basics. It's not worth doing that. So we favor on-demand knowledge and also mixing concepts. So yeah, there are things that are advanced, there are things that are more intermediate, and also there are things that are more basic. They all are mixed together. I know, and I have seen so many times that if a person can keep on studying and doing the exercises, and the proposed exercises and so on, this person is already intelligent and capacitated enough to really figure out and understand and put the pieces together, and that's it. It's not so hard. It's not so difficult as some people may try to pretend to be. We can do amazing stuff if we just keep studying and making and trying to do it and trying to understand. We can cover huge ground, huge subjects, advanced, intermediate, basic. We can do that.
I like how the basic subjects, in a sense, are more advanced, but if you treat them as basic and go back to it later, then you can start working and performing the functions that the job might require, and then grow your skills through those basic understandings, like at a future time.
Yes, it's like a spiral. I treat knowledge like a spiral. You keep revisiting stuff, but from a different perspective, and this spiral is going up, and it's one entire thing. But when you started here, you are going to revisit it here, but from a different perspective, and the same thing is happening here. So all these specific points here, they are the same thing, but from this different perspective. But basically, they are the same thing.
That's a great way to look at just any kind of an evolutionary system, because we use the same pieces over and over again, and then we grow because of how we've changed relative to them and how we treat those circumstances and situations.
Mm-hmm.
That's very interesting.
I think it also applies for everything that humans can learn, or consciousness can learn, can understand, can relate to. It's the same thing from different perspectives, and I try to think that we are growing, but sometimes I have some doubts. I think we are doing this.
I like that. That was a good addition. You could either draw the up arrow or the down one. It's like, maybe it's this one.
Maybe we can do this, and we are going up and down. And so it's a horizontal spiral, not a vertical spiral. Maybe it's something like that that we are doing. I don't know. I'm not so sure. But nevertheless, we can really make use of this knowledge in the first day, if necessary, since the beginning. We don't need to be 10 years in the studying and reading books and doing some courses. After 10 years of doing that, we can write our first line of code in real scenarios. Not like that at all. We can do that since the first day. We can write real things since the beginning.
And that's why you said, I think, like, a lot of these jobs, you get trained on the job, because it's not about those fundamental, the basics that you learn. It's about how to do that specific job and that task. And so they have to just show you how they approach it and how they try to accomplish it. And it might be different depending on the business and the things that they want to do too.
Yes. I have a real world example here. I have fixed a comment from one of my students. He mentioned Saturday, a good day to take care of personal projects. I know him personally. He was the bricklayer a few months ago. I forgot how to say it correctly in English again. Sorry, but let me check.
He laid the foundation?
He was a mason.
Oh, Mason.
So,
Oh, a literal bricklayer. I see.
yes, he was literally a bricklayer a few months ago, and now he's a developer working in a real company. I think it's going to be 9 months since his beginning as a developer.
Oh, wow.
And
That's
he's
amazing.
working. He's working. He's doing his job because obviously he has studied and he's still studying, but he's learning, and as he's doing the job, he's learning as he goes. Just a proof of what I'm saying. Okay, let's go and yeah, let's try to call this function. So what's happening here? My code is not running. I have this Spring application, but it's not doing anything. I haven't clicked on the play button. So there is a play button here. When I click on it, the application starts. It's like playing a song. So right now, this song is not being played at all. Nothing is happening. When I click here, the application is going to start in my local machine. It's called localhost. So localhost is another name for your computer, your own computer that you are using to make the development, to do the stuff, to code.
I see.
And it's building. So it's trying to, it's going to build the application. In other words, it's going to compile the code to make it ready to be used. So it's doing this. This is called logs. It's logging what's trying to do. It's a bunch of things happening because we are using some frameworks. We are using Spring, and Spring is a bunch of libraries. So
Oh, yeah. I saw that when I ran it locally through the command prompt.
good. That's it.
Showed Spring.
And there is some error happening. Why I know it's an error? Because it's a bunch of at. It usually showcases something is not correct, something is wrong. I need to understand why something is wrong. It's a huge topic on itself, but when I mentioned to you, try to run IntelliJ community locally in your laptop, I was expecting some problems to happen. And when you try to solve these problems, you are also learning real world skills.
Oh, yeah. I ended up having to uninstall everything and just reinstall it. And when I did that, it was pretty easy the second time. I had just screwed up the install. But yeah, it made me go through a lot and think a lot. So it was instructive. I did learn.
Yes. There is a saying from Chinese, I think it's Chinese wisdom, not the actual Chinese people, but from the past millennia.
Yeah.
They said something like the master has failed so many times that the disciple even tried, something like that.
Yeah, that's interesting.
So the real thing here is try to do so many things and fail so much and try to fix them so much that the beginner, he just got his first error happening, and the master is at the hundreds of thousands of occurrences of happening the same error. So
Yeah,
that's
it's like
what's defining him as a master.
it's like unit testing.
Yes, it's something like that. We failed so much on unit testing that we can consider ourselves a master in unit testing because we failed so much.
Well, yeah, you have to know where all the failures are in order to be able to address them.
Exactly.
So it's like if you failed more, then you know all more ways that things can go wrong, and so you can prevent it from happening by being aware.
Exactly. That's a sign of a good developer. So
Yeah, I think the thing I noticed is like when I'm coding, there's a point where I'll make sure to code myself to start and see how I think of how to approach it and what my instincts are. And then at a certain point, I'll recognize, okay, I'm going to be wasting time if I keep trying to, if I keep beating my head against the wall and trying to figure it out. And so I just need the answer. And then I see what it is. And then it helps me to like integrate and incorporate the information. But that doesn't really exist, I think, with some of this stuff because you can't just get an answer to it, really. You have to figure it out.
yes, and that's why sometimes I ask for the student to avoid using AI, because the AI will fix the problem probably so fast that the student won't get the opportunity to learn from the mistake. And sometimes that's well and good, but especially when the student is not really looking into become a software developer, so he or she's just looking to see how it is, but he or she is not going to really work on with that. And in that case, go ahead, use AI. But if the person is looking for working as a software engineer, it's good to have some mistakes and bugs and errors locally in their own local host, and try to manually figure out what was happening and fix.
Yeah.
It's going to be better.
Yeah, you have to see like how you apply everything that you know, that it makes you use it, it helps to integrate it. And then if you hit a point where you go, okay, now I'm just searching in the dark and I really don't know what I'm doing, but I've tried. I think that's a good time to get some guidance.
Yes, totally agree. You don't need to keep bashing your head against the wall.
Yeah.
It's not necessary. But at least some trying. I usually suggest 1 hour of trying. So try alone for 1 hour. Alone meaning searching on Google, Stack Overflow, searching on documentation, trying things for yourself during 1 hour. In 1 hour, if you couldn't solve the problem or the issue or the bug, then you can ask AI or ask myself. You can ask me what's happening. Probably I will know something to get out of the situation, the error, and that's it. That's enough. 1 hour of trying alone.
It's important to know how to teach yourself.
Yes, really important. That's makes all the difference. And here I don't understand what's happening, because why I don't understand it. We are also doing a pair programming here. It's another thing that I will teach you about later on, pair programming. So I will explain to you what I'm thinking, and by doing that, you are going to learn new things, and also you can propose some solution that may be the case, and it's going to solve the issue. So it's called pair programming. And I don't understand why the application is complaining about the database. Why the database? Because here at the end of the logs, it's mentioning the DB. DB is database.
Database.
Yes. It's is mentioning a no host exception. In other words, it doesn't recognize this name as a valid host.
Oh, and so an exception is just a word for error, essentially.
Exactly. It's called exception. It's important to mention this earlier on, because why it's an exception? There is this normal flow, execution flow of the application, of the code, of the function calls or method calls. This is the normal stream. And when something unexpected or bad happens, there is an exception, and this exception or this unexpected flow, it's called the exception, because the green one is the normal behavior, and the red one is called the exception.
Oh,
so
I see.
The exception to the rule.
Oh, so it's not that like the code crashes entirely or something. It just does something it's not supposed to.
It may be both cases, depending
on
the specific kind of exception. It may crash the application, but it may not. It may keep going on, but something was strange, something unexpected happened. So an exception. And it's a change in the normal flow of the application. That's why it's called exception. Most of the time, the exception is going to have a stack trace or trace back or list of steps before the exception. So let me just put this one in one line. So depending on the language, it may be called stack trace. In Python, it's called traceback. And there may be other names for this, but at the end of the day, it's just a list of steps before the exception happening. Why? To help the developer troubleshoot this situation.
I see. That makes sense. You want to see what processes the code was going through and what objects and numbers it was dealing with. So you can think about,
Exactly. By the way, if you need to go, you are free to do that, right? Because I tend to talk a lot.
I'll stick around for. I'll stick around. I feel like if you have things that you feel are worth explaining, it's good for me to hear it.
Okay, that you may have some things to do and place to go. I personally, I'm free today. I just need to do this stuff that I'm presenting to you while I speak. I need to troubleshoot things, and at the end of the day, I will have the data on Grafana, as I mentioned, but it may take some time. I don't know how much it's gonna take. But when you need to go, no problem. I can just keep going here, and you can check the recording later on if you want to.
Oh, okay.
So, okay, these exceptions, they are going to happen in any programming language, either it be Java, Python, any other language. They are going to happen. And the common behavior is to give back a stack trace, a trace back, or it may have any other name, but all of them are going to be this list of steps before the execution happened. And in case of Java, it's called stack trace. And here is the stack trace. It's all this stuff. It's fearful for some people, and it's not to be feared because it's going to help us troubleshoot what's happening. And it's called a stack trace because it's really a stack of things, one above the other and in sequence.
Do you often use AI to help sort through this data?
Yes, nowadays it's really good to use AI to do that.
That's what I did
Sometimes,
when I was locally running the first project that you had me clone the website.
go ahead and use it. I just ask you to ask the AI to explain to you what was this stack trace about.
Oh,
So
okay. Yeah.
ask the AI, why is this happening, and explain to me step by step.
Yeah.
Something like that. Because if you go directly to the answer, you are not going to extract any benefit from the actual learning process of understanding the stack trace itself.
Google's AI does a pretty good job of always making sure to explain everything, I've noticed.
Yeah, I also noticed that, but sometimes the person may have set up the AI to go directly to the answer. So we can do that. For example,
I never thought to do that.
Yes, for example, Gemini. We can go to this icon here and personal context. And we can instruct the AI to go directly to the answer, for example. Some people do that.
Oh, interesting.
And Cloud and ChatGPT, they all have this option of defining some directives that the AI should follow when answering you. So in case your AI is not explaining what it is doing, you can set up some instructions beforehand to make sure the AI will always explain to you important things. So it's in Portuguese, but I basically telling some stuff about myself and what are my preferences. I have mostly where it is, I forgot where it is, but mostly I teach the AI to tell me when I'm making some fallacies because I write some text, an article or essays, for example, and I put it to the AI, and I ask the AI to tell me if I'm doing some fallacies or logical mistakes and their cognitive bias, for example. So I ask the AI to always warn me if I'm doing those things. But the most important thing is to get the explanation and understand what the AI is figuring out, so you can extract the benefit in the learning process. Okay, so going back to my reasoning, I don't understand what's being shown here because it's saying a no host exception, meaning it doesn't recognize this host here. But in my it should, because in my Docker service, Docker is just a way of running applications.
Oh, you can run here. Docker within IntelliJ, or you can talk to Docker. Oh, okay.
IntelliJ is going to be an interface to deal with Docker. So it provides us the interface, but Docker itself is running separately. So in Windows, for example, Docker desktop.
Oh, I see.
Open it in a moment. Here, for example, this is Docker desktop. These guys here, they are containers, and they are running. That's why they are green. So they are running, And if we look closely, they are the same from this other view. So they are the same. For example, Prometheus, it's here, and also it's here. It's the same. So I prefer to use IntelliJ because it's an integrated environment, so I can deal with Docker without needing to open another window. So I can do what's needed through here instead of opening a new window and so on. But it could be done through the other window as well. And this database, it's running here, and it has the exact same name that the stack trace is mentioned that is not understanding. That's why I don't understand why it's complaining about the name of the database, even though or although it's here. So something that I need to understand. I don't know what.
Oh, okay.
Try to figure out.
Is it, and it's all spelled the same?
We can check. Good thing. That's it. That's pair programming. We are talking with each other about how to solve the situation.
Oh,
develop the feature.
That makes sense. It's a lot easier with some reflection because otherwise you kind of stay in, you know, a one headspace. It's easier to talk about it.
Exactly. So let's check the name. It's a good idea. It may be the case because even a single letter difference can go wrong. I will try to get this name. Let's see, how can I copy this name? Copy container ID, copy image ID. Let's try to copy image ID.
Yeah, it's really interesting in Java since you can't even change the capitalization on a word without the system ceasing to recognize it.
Yes, most of the time they are case sensitive.
Oh, that's what I meant to say. Yeah.
Yes, case sensitive. Most of the time there is exception, or there are exceptions, but let's not talk about them right now. I don't think they are important. Most of the time it's like that. I'm trying to copy this name here, but the interface is not allowing me to do this. So let's try something else. There must be a way to just copy this name.
Yeah, that's interesting. It's making it a challenge.
Yeah. So probably we should open a feature request for the IntelliJ guys that have created the IntelliJ.
Oh, interesting. Or maybe something kind of abstract, like how you search just by typing, which
let's try
that
that.
was a surprise.
Oh, there is. We can just type the name, which stands for new online
pages, or what's
Peças?
Peças or
Peças? Yes, it stands for items, for example.
Oh, items. Okay. Novo Peças.
-db. So there is an exact match. So it's safe to assume that this here,
you can copy it.
you can, yes, exactly.
Oh, it won't let you though. Oh my gosh.
Oh, it allowed me.
Good.
It's here. There is a specific tool in Windows called Clipboard Manager. I tend to use it. It's called Ditto. It's an application that we can download, and it's going to manage everything that we copy and paste. So I type a specific keyboard shortcut, and it shows up what I just copied.
Oh, that's cool.
It's like a second brain. Because
That's
if
handy.
you don't remember specifically what you were trying to paste, you can write partially. For example, level here. Let's suppose I wanted to have this, to paste this level. So I just type it level, and it brings up what I need. But it's really fast to search things that I have already worked on.
Oh, that's great.
Later on, you can install it on your computer, but it's here. Let's check. Oh, it's here. Peças Online TP. And where it's coming from? Peças, this name is coming from Docker Compose. How do I know that? Because here we have this Docker Compose. Docker Compose is a way of calling a bunch of Docker containers at once.
And what
the same
are the
time.
Docker containers? I think that would be helpful to understand.
Good. Usually, we have an image and a container. The image is like a class in Java, image. And the container is like the actual object of the class. Container is it's derived from the class, from the image. And what is the image? Or remember, we are in the context of Docker. So Docker, it's here. Docker, we have the image and the container. The image is like a blueprint for something.
Of the classes?
For the classes, for the blueprint, for
Oh,
the
the classes.
base.
The classes in the image. Okay, so the classes are the blueprint and the image is also the blueprint. So is it the classes?
Yes, like in an analogy, yes. So the image by itself, it doesn't do anything. It's just a instruction. It's just the recipe for something. In case of Docker, it may be, for example, the recipe for a database. Like here, for example, we have the DB, which is for database, and we are using Postgres. Postgres is the name of the database. Like Oracle DB, like MySQL. Have you heard about these names before?
Yeah, those are familiar. So this would be a collection of classes or a collection of methods.
Yes. The difference is they are all put together in a usable way. So you don't really need to understand the details of how this Postgres image is going to work. You just invoke its name here and do some a little bit of configuration. Never mind that for now.
Oh, I know. I understand this.
Yeah, it's here. So we are using Postgres database.
Those are placeholder names, right? Like DB host and Postgres database. Those will come from a user, for example, on the internet, or it will come from a database. Actually, the database would fill those fields. Is that right?
Yes.
So the user comes from the user.
This is the username of the database, like the credentials. So you can access the database. The username and the password for the username. These guys are going to come from a user, as you mentioned. And in this case, the user is myself.
Right. And so the user puts in their information, and then that accesses, or that is compared to the database from the
It is,
host.
yes,
So the host has the database. So Postgres DB is held by DB host, and that receives the username and the password from a terminal.
yes. DB host is the address where it's located. It's not something easy to understand, okay? But you are going there. You are quite right. So don't bother
It's
to
just missing.
remember by heart.
Oh yeah, I see. So it's like it's missing the IP address right now, but once it gets it, then it's like that's how you tell it which repository essentially to draw from for the information for that database. But you could take this and use it for various different hosts. You could have clones of that same database, or you could put it on different computers. But once you have the IP address, then it's like, okay, this is the database that you're using. And then it will check, is this username in that database? Is this password in that database? And if it is, it produces a result of some kind.
Yes. And look, it's an image.
Yeah. So that image is on the DB host, essentially.
Yes.
But
Which image? Postgres.
But that image, okay. So Postgres is not the database itself. The database would be made up of things like user and password. Which
Postgres is the type of the database.
Oh, it's what kinds of information it stores.
It's the engine. It's the engine of the database itself, because the database, it may be Postgres. I will show you alternatives. For example, it may be MariaDB. It's like vendors, flavors. For example, Coca-Cola and Pepsi.
Do they all
They are
accomplish
beverage, but they are from different companies.
Do they all accomplish different things then, or is it similar tasks but with slight differences?
Similar task, but slight differences. But in the end of the day, at the end of the day, they are all databases, but with different flavors.
But there's so would you say? Oh, sorry. Would you say that there are two parts to databases, and one is sort of the static image data that doesn't change, that's just how it's structured, and then the other part of a database is the variable kind of user data, the things that require an input of some kind, and it is like a shifting database that changes due to input.
What you are describing?
Oh, that's the container. Okay. So the container is like a shifting database where the image is more like version 1, version 2.0, version 2.2, and that only updates as the software like changes, whereas the container is like me opening a certain game. Like I open League of Legends, that's the container. I'm now putting my information, my character in, it has my statistics and my data, but the image it's version 16 of League of Legends or something.
Exactly.
That's interesting. Oh wow.
So the container,
I'm sorry to keep interrupting. I get a little like excited about it. It's interesting it's interesting to understand. Like, so the image, like Postgres, will be used by a lot of different web hosts and a lot of different programmers. They'll be using the same image, but their containers will all be unique depending on the business that they're working with or the task that they're trying to accomplish.
Precisely. We can, from one base image, we can derive or get lots of different containers.
Wow. Oh, cool. That's neat.
This is the basis. That's why I mentioned it's like a class. And you can have many instances or objects of this same class. In the context of Docker, they are called containers.
I'd been having trouble understanding the difference between classes and instances of the classes. That makes a lot more sense. And so classes themselves, that's why they're called static, whereas instances are not static. They're just however many instances are created.
Yes, I will try to explain the same concept, because remember, at the end of the day, they are just the same thing from different points of view. So even though Docker and Java or JVM, they are separated, the concepts are the same, but they get a different label to them. But I think it's going to be clear now. Let's mention, okay, this code.
Yeah, this is very interesting. I like seeing how a lot of the same principles repeat. So when you talk about your pyramid, like it's when you work with the 3 different levels, you get a chance to see the same concepts in 3 different ways too. So you're always learning about how all these parts
Yes,
work.
they are interconnected. And the same, I think it's going to be clear now. The question about instance and class and object. So here we have the code perspective. Literally the code. So for example, here we have the code. We have a class here. Look, class. And it's just code. It's just a bunch of text. Nothing is happening here.
And it's an abstract class because it's using a database of some kind, or?
Never mind this for now.
Oh, okay.
Just focus on the class and the name of the class. So class meter registry. Let's copy this name and put it here. So it's just code. It's just code. When you click on the run button, this one, when you execute the application, you play the music, play the song that was stored in your computer, or when you access the Spotify, for example, and choose your song and play it. When you play it, it's the same thing happening here. It's going to create something. In the case of the song, it's going to create the song itself that can be heard. In the case of the code, it's going to instantiate the object of the class that you were just referring to. And the object lives inside the JVM memory, because it's a running thing. It's happening in your computer. It's taking memory. It's taking CPU resources to compute.
Right.
So when it's just code, it's just class. It's just the blueprint. But when you click on the run button, something magical happens. It turns into an object during runtime.
Oh. And then you need to know how to talk to the object in the code too. Is that right?
Yes, most of the time we do this through abstractions, through method calls or API calls, or most of the time that's it. API calls and method calls or function calls. The first function that we call, and that's why we have the main function, it's a special case. It's the entry point. Entry point. So the main function, not only in Java, but in most languages, there is the main entry point that carries on all the other calls, all the other classes, all the other functions. This main entry point is what's being called when we click on the play button. So this is the same thing. So there's a
that's
play
what puts
button
the
here.
play button there. Oh, I see.
Yes, it's the IntelliJ does that for us to easy our lives, to facilitate our jobs.
Oh, yes.
In the past, it was done differently, but it doesn't matter right now. But it's the same thing. It's the play button here and also the play button here. They are the same. It's calling the main function, and the main function, it's running the application. So run application. It's like the first train. I forgot. There is the payload and the first. How do you call this first thing here on the left, on the right?
Oh, the engine.
The engine. Yeah, it's the engine. So the main method is the main engine here. And all the other things are going to be carried on by it. All the other classes, objects, functions, variables, and so on. Why it matters? Because here.
So is it inside of a main? Would it be a main class? Is it called, or is it a main something else?
Usually
Class
it's
main.
called main class.
So inside of a main class, it's essentially a way of saying, here's all of the things within this class that can talk to each other, all of the systems that can talk to each other. And then main goes and it talks to other systems outside of itself through being called as a function.
Yes. And the main difference that I want to emphasize is the main point is the class itself is only code, doesn't do anything, but it's the blueprint that makes possible the instantiation.
Oh, okay. And so when a main class gets called by other parts of the program and is, for abstraction, I guess, the definitions within that class are not relevant. Like those are not explicit to other parts of the program. They're just contained inside that code, and it does what it does because it's putting out those objects that have a specific function. And so at that point, you're no longer talking in the language of the code itself, but you're talking to the objects and just asking them to do different things.
Exactly. Believe me or not, but most developers doesn't know this. They doesn't care. I'm teaching you
they don't
some
need it. That's funny.
fundamentals. But with these fundamentals, everything is going to be easier. And that's what's happening. Code turns into JVM stuff. In code, it's called classes. In JVM, they are called objects. And they occupy memory, they consume CPU.
And it can create as many instances of those objects as are called for or are needed.
Yes, exactly. That's the next step. So with one class, you can create different objects. And from the same class, that's called object-oriented programming as well.
Oh, that's where it gets its name from. Oh, I see.
Exactly. That's why it's not called class-oriented programming. It's called object-oriented programming. Because from one class, you create many objects and you deal with them, each one of them case by case, or it's possible to deal with them together or alone or by themselves. There's many possibilities here, all because of this paradigm that I'm presenting. And I will even put the same color here. Let's change for something different. Here, so it's green, and it's green. So the image from Docker is green, and the class from Java is also green, because essentially they are the same thing. They are a blueprint that you can instantiate anything. I will change the color here. Okay, yeah. So these containers are blue. The objects are also blue. That's not by chance, it's by design to emphasize that they are the same thing from different contexts. One is the context of Docker, the other one is the context of Java. So I can even do this. I think it's going to be good.
Would you call each object in Docker a container, or do containers have a multitude of objects?
Inside the container, there may be different things. They may be a database, they may be another container, they may be many different things. But you can call all of them different objects. For educational purposes, no problem.
So containers are sort of like an intermediary step between the hard drive and RAM in terms of how programs will run and store data in RAM when it's active and in use.
Yes.
Containers are kind of like that, but they're frozen until you're accessing them. But they are what gets accessed rather than the image.
In case of the container, when they show up, there is already memory allocated to them, memory and CPU. So they are analogous. Let me change the color here. Okay, it's better. So see, the JVM, which is in blue, it's consuming memory and CPU. Also, the containers, which are also in blue, they are also consuming memory and CPU because they have been instantiated from the image. So they are running. They are existing things in memory.
Oh, okay. Did you say that they are consuming memory and CPU, or the CPU or the memory? It's just they're consuming memory.
Both.
Oh, okay. And so once it's in a container, so something can sit in RAM without consuming any computation cycles, right? So for a container, does a container need to be being processed, or can it just sit in RAM, or it seems like it can just sit on a hard drive actually.
That what you just mentioned applies to images. So it's consuming only hard drive space, but they are not running, so they are not consuming CPU and RAM, only hard disk.
Oh, okay. So the containers only exist temporarily. Like when you turn off your computer, the container stops existing.
Exactly. The same happens for the JVM and the objects. If you stop the JVM, the objects die. They disappear. The same happens for the containers. They disappear. And the class itself, remember, class is just code. It doesn't care if the computer is on or off. Even if you shut down your computer, you turn it on again tomorrow, the code will still be there because it's stored in the hard disk. The same applies for images. They are going to be stored statically in your hard disk. They are only going to be acted upon or turned into something when you run them, and then the container are created. It's
and
the
so
instantiator.
For those containers, they need to work off of some kind of a set of stored variables. But those stored variables are not always in the image, right? Because those stored variables change between different projects. So where would those be?
Good question. it may be defined by default some basic configurations, variables, just for the sake of making the image usable. So basic usage of the image. So there's this possibility. And also we have the possibility of having specific configurations and variables for each container as well. So there is a broader configuration that applies to the image, which are basic ones. And also we can define specific configurations for each container case in a case-by-case basis. So we can have both. And here we have one example. Now it's going to make little bit more sense. These things here, they are specific configurations applied upon the basic image. But if I enter the image itself, it's possible to do that. I'm not going to show it because I will need to go to another Docker Hub page. But yeah, trust me, there are specific configurations already defined inside the image itself, but I'm overriding them with my specific configuration here.
And where is the Docker, what do they call a container? Where is the Docker container referenced in all of this? Because of course, DB host would be the thing, I guess I thought of as a little bit like what I thought the Docker container was. It has all the data on it. Container name. Oh, I see. So, okay. So that's its own. Basically, it goes to DB host and it looks for that container name. And then it creates a container out of it.
Yes, I can do this. I can do this live. Let's see.
Oh, so containers are really made out of two databases. It's made out of the image, and then it's made out of the specified database that is different from project to project.
I think I see here. This only specifies the address. It's arbitrary. I can use a proper name here. Okay. I think it's going to be better like this because, okay, so
for the IP address.
Yes, I'm telling the container, specifically this DB2 that I just created, define it. I didn't create it yet because I didn't run it. I didn't click on the play button yet, but I have defined another database that I'm calling, let me just fix this here. I'm calling database 2. So it's gonna be called database 2. Okay. It's based on the same image, so the same name for the image, Postgres version 17 Alpine. Postgres version 17 Alpine. So same base.
Would you say that essentially Postgres, from the point of view of, say, Docker, cannot change, but it expects the DB host database to change? They're both databases, but it relies on Postgres not changing while it's running, whereas the other one can change. And it expects that.
The image itself is not going to change, but the instances of the image, which we call container, they may change. They may be totally different. Not totally different, but different enough to be used in a different way. Because the base itself remains the same, but the instantiation of the image, which we call containers, they may change, for example, the host. For example, here, I can define the host address, DB. I can call it like that, first or second. DB host address. Just duplicate it here. And here I can call it first DB host address. So I'm defining this. Let's suppose it's going to be localhost, like that.
Oh, now you're giving a connection between the different parts, whereas you could just say database and host, and it's like it already knows it's under database 2 or under database 1.
Yes. Could you repeat? Let me see if I get it correct.
Oh yeah. So you don't need to make it clear within the code that there are different database that these are relative to, because above you say database 2 and above the other one you say database 1. Yeah, right there.
Exactly.
And
I can change the container name. Remember that here we are naming the container. We are not naming the image, because the image, it has a fixed name.
Oh, I see, right. And so Postgres is it's just outside of all of this because it's defined somewhere else very clearly and is being imported, but all this other stuff is variable.
Exactly. We are using an abstraction. It's is also an example of abstraction. If you search for Postgres, for example, Postgres here, it's a database. It's a flavor of a database, because there is a bunch of different names for database, and each one of them, they are in the category of the database because they store data in a structured way. And we can store data there, and we can retrieve this data easily by using SQL or SQL commands or instructions. That's the definition of database.
Oh, I see. And are these databases tailored to different functions? Like, is it a user base? Is it a database to store user information?
Yes, there are different kinds of database for different purposes. Sometimes they are just different enough, not so different, but different enough to be considered another company behind them. So it's not like copyright infringement. For example, the case of MariaDB. There is a bunch of dogs making noise here. Can you hear them?
Oh, yeah, that's okay.
I hate these dogs. I'm having some troubles with dogs this year.
They have a lot to say.
I need to forgive them because they are causing so much trouble to me.
They're a good example of how to do that, I guess. they sound like you'd have to figure out how to tune them out a bit.
Yeah, there's a bunch of spiritual lessons for me to learn with them, but I'm not learning anything with them.
I always find that's a worthy pursuit. Like, if something bothers me, I think I'd rather not be bothered instead of trying to get rid of the thing. I'm just like, oh, what if I just didn't mind and have to find my way there? That can be really hard, but I think
I'm trying to do that.
If you can do it, you're like Superman, you know? That's pretty cool.
I'm enlightened being.
Yeah. You're gonna like see the heavens or something.
Yes. I want to do that if possible, but so far I couldn't.
If possible is is doing a lot of work in that sentence. That's an important concept.
Okay, so yeah, about why there is different names for databases, because there are companies behind them, and there are many ways there are many ways that a database can be created. But most of the time, they do the same thing, fairly speaking. And it's just a way of creating different products. It's like a car, for example. There are different vendors for cars, but at the end of the day, they are cars. There are Mercedes-Benz cars, Chevrolet, and Hyundai, and Renault, Fiat, Ford. There are different companies behind them, but they are cars at the end of the day.
Oh, so
It's the
all
same
these
for database.
all these databases have a bunch of different classes on them that are designed to perform a specific function. And so do those classes, what kinds of classes would they be? What are they doing exactly? If there's like a broad summary of that.
Storing data
Storing
in a
data.
retrievable way.
Oh, okay, but it's not like predefined what kind of data, like user data or something like that. It's something where you can adapt it to whatever you want to do with it, I imagine.
Yes, they have a broader category that we can make use, but they are generic enough that we can use them in specifically tailored ways based on our use cases. For
Oh, I
example, they
see.
may store strings and numbers and lists, but they don't specify which kind of string, which kind of number, which kind of lists.
Oh, so it's
That's
just
just
it just manages arrays so that you don't have to really.
yes, and they manage it in a way that we can easily retrieve them when needed.
And
For
rename
example,
them and
rename
all that.
them and structure them and also relate them to each other in a certain way. For
That makes
example,
sense. That'd be
here I
pretty
have
fundamental.
the fundamentals. I have here my downloads folder, and it's totally random here. So a bunch of random things. But never mind trying to read that because it's just random. Just random.
Oh yeah, I'm just paying attention.
If I try to find something here, I will need to write the name in the search bar so I can get to what I need. Because
Right.
it's so random. Imagine there is millions of things here.
Oh, does Postgres like index stuff the way that Google does
Yes,
for access? Oh,
exactly that. It's a way
oh,
of
that's interesting.
helping us to retrieve data. Because if I have only one item here in this download folder, it's going to be easy. There is only one thing. I just click on it and that's it. Most of the times, that's not what is going to happen in real world scenarios, databases, and so on. There may be trillions of items in a database. And when I need to retrieve or read a specific item in these trillions of data, if I don't have a database specifically designed or dedicated to do this efficiently, I won't be able to find the item that I need, even in 100 years, because there are trillions of items there. The database that we are talking about, they have a specific name, a specific flavor, specific use case. Sometimes they are not so different between themselves, but they are different companies. There are different companies behind them because they are specifically designed and created to be able to retrieve data, even if there are trillions of items stored in them. So they are engineered to this. One of them, it's called Postgres. Other one is called MariaDB. And other one is called MySQL. And
So
why
these-
did I... Go ahead.
These all generate searchable lists out of the names of everything that is stored on them, instead of like
Yes.
iterating through every object to,
Yes.
to compare its names and everything. It just goes through the list.
Yes.
Mm.
And
So they're made up of classes and lists, essentially.
yes. But the main difference between them and this code here, for example, that I have, is that my code is designed for a web application that creates a JSON for the front end to use the JSON in a certain way. In the case of the database, it's designed to retrieve stored data in a certain way and outputs this specific data in a table, like a CSV, or comma separated value, or a Excel spreadsheet, for example. So different
so
from JSON.
CSV is essentially the format for how arrays are stored.
Database, basically, it's a huge, really huge CSV file. I'm not kidding. It's something like that, comma separated values. So this is an example of how a database is structured. Most of them, not all of them, most of them are going to be a bunch of lines like that, separated by a specific value. Most of the time it's going to be comma, or this stuff here that I forgot how to say in English.
Semicolon. Would you say
Semicolon.
would you say that this information is stored? Okay, for one thing, would it be stored in an array, and would it be stored sequentially, or is it more about is it logically stored with things are grouped together? And is it stored to make sure that the memory is used efficiently? Is that a big part of it?
Yes, it really is. Most databases are going to use an array, basically, but in a sophisticated way for it to be performant.
Memory efficient.
Exactly. But grossly speaking, it's going to be an array, a dynamic array, an array that can grow up and down. And it's also going to be stored in a hash map fashion.
Oh, okay.
For reasons,
keys and values.
Keys and values. It goes really deep in data science and also computer science and data structures. I can teach you most of the things that are happening in the background in a real database, but I don't think it's worth right now.
Very interesting. So thank you very much.
Really complicated. But basically, it's a hash map with an array. It's like a dictionary. And for us humans, they are going to look like that, like a table separated by semicolon, for example.
So those hash maps that go to these arrays, do they go through a number of, let me think how to say this. I'm trying to think of how it would be stored, like how the information is stored together. Could a hash map go to an array, and then that creates another key in that array, and then that goes to another array? Yeah. Is that how it's set up?
It's called B-tree.
Oh, what's it called?
B-tree.
Oh, interesting. Wow.
You may want to study some data structures because they are really fascinating, and I know you like that kind of stuff. You may study them because I think data structures are the most important thing for a developer to know.
Well, I like the logic. It's interesting to know how these problems are approached.
Yeah, it's fascinating. There is a specific site that gives us some visualization for them. Let me check. Oh, I will just open the website. It's going to be better. Data structures visualization. I will send you the link later on.
Oh, okay.
Or right
Thanks.
now.
You're really good at explaining this. I think a lot of this information feels like very dense and overwhelming if you try to just approach it yourself.
They
So I
are.
really appreciate the
But
explanations.
they are really interesting. And it's good to know it's recorded. You can just rewatch it later on if necessary. And one of the things that I like to do when recording these lessons, for example, in 1 year from now on, you can just go back to this live stream and rewatch it, and you are going, no, that make more sense now because you are going to have more knowledge and more context. So there is so many layers to what we are doing right now.
Yeah, I can see that.
B3. We can visualize what's happening. Most of the database that we are talking about, they use B3s. There are some exceptions that uses different data structures, but let's leave it for the future. For B3s, for example, let's insert something here. Blah. XPTO. Christ. Okay, let's insert something totally different. Oh, there was a split.
Oh, okay. So it starts by storing all three as a single array, and then it uses blah as a key to get to the other two instead.
Yes, if I try to use another word starting with ABC, let's see what happened. ABCD.
Oh, it's associating it with 1, 2, 3, 4 because perhaps A, B, C, C, D is also a linear structure that is progressive. The same that 1 goes to 2, goes to 3, goes to 4, A goes to B, goes to C, goes to D. Is it doing that? Is that part of the logic?
Yes.
Wow, that's really interesting. So it's using a lot of different associative kinds of understandings to see which things are associated with which other things. I wonder why it associates XPTO with
probably
blah.
because both of them are only letters, and not yet we have a closer association for XPTO closer than blah.
Oh, but A, B, C, D, and 1, 2, 3, 4 are still closely associated to each other. So it has to put them next to each other and then draw a line back to these other things that don't have as much of a pattern.
Exactly. And it's doing this based on a semantic tree.
Oh, okay.
Some AIs also use this behind the scenes. Trees and semantic association. Let's try to find something and see what happens. I will try to find XPTO. Okay, so it first searched on the first branch, and it didn't find what we were looking for in the first branch. So it tried to the next thing similar to it, and it will find XPTO. Let's try putting something random things and see what happens.
You're trying to see if you can get it to split again.
Yes. let's mix them together, numbers and letters.
What if you put like a complete word in? Oh,
Hmm.
oh, interesting.
Numbers and letters made a split.
Ah, oh, I see.
Look, there is a number 2 here and also number 2 in the branches, the childs.
Oh, yeah.
Let's try to put something that starts with X. Let's see
Oh,
if
this
it's going to go through the right.
this must be what people use to crack passwords.
Mhm.
That's really interesting.
There is a specific thing about this. I was watching a YouTube channel called Veritasium. I don't know how to pronounce it, but it's
Oh, yeah,
something.
Veritasium.
There is a
I've seen his channel.
I forgot the title of the Markov chains. It's called Markov chains.
Oh, okay.
So Markov chains is a way of predicting the next probably meaningful word or sentence.
Wow,
It's also used when we are writing in the smartphone, for example. Yes, also in the search.
It must be AI must use it as well, for sure.
AI also use it. That's why he's mentioning these logos here, including
the ChatGPT.
Because nowadays it also uses Markov chains.
And Spotify would use it to determine what similar music users might like that it could recommend. How interesting.
Wow. If I write here, for example, my name, it can auto-complete with Robert or Robinson or Robert.
So when it's storing those trees, those B trees, that's more about how to structure the database so that the list it has to search isn't too long.
Exactly.
Oh, wow, interesting.
Because we have limit time and limit CPU resources and memory. If we had infinite resources to search, it wouldn't matter the way we are searching, because at the end of infinity or sometimes during the infinity progression, we are going to find it anyways.
Yeah, that's interesting.
Because we don't have it, we need to use these algorithms.
That's interesting. Like sometimes by making things more complex up front and trying to perform this more complex task of sorting them, where it seems like, oh, it would be a lot simpler just to put things in alphabetically because that's a very simple system. In this way, it's sort of like you're just doing some of that computing up front. You're doing the computing time and then taking a picture of it so that it doesn't need to be done later with that very linear method. But it's just restructuring the information itself to make it more accessible to the computer.
Yes, or findable, because the whole reason is to find it as fast as
possible. Yeah, otherwise it'd just be overwhelming to the computer.
Yes.
Yeah, that's interesting. I like that you said that it has to be findable, because in a sense it's always findable, but if the list gets too long, then from a certain point of view it stops being findable.
Yes, even though it's there, it's not feasible anymore to find it.
Yeah, or at least in the time frame required.
Exactly, because even if you can find the data in 1,000,000 years, it's not feasible, it's not practical, doesn't make sense. Even though it's possible, it's not practical. So,
this is why algorithms are interesting and the math is interesting, because it's taking the same set of data from a point of view, and then it is looking at it in a way that shows how the parts are connected. So the more connections you can make between things rather than just having them exist in an isolated fashion, the more advanced both that storage method becomes and your ability to use it, and the more advanced your understanding of information itself becomes. The better your understanding of information is, the more links you make between it, the more you see like AI being this very emergent thing where they say we don't even really understand how it works, because it's working with the fundamentals of information itself as a thing, which is really fascinating. Oh,
It is.
information theory. Oh, yeah. Is that what that's
If you
about?
want to, you can go down this rabbit hole.
Oh, that's cool. You know about all this stuff and like connect all these pieces that way. I find I have a lot of things I'll think about where I sort of just find my way into thinking about concepts that seem almost disconnected or maybe philosophical. But then I talk to somebody who has a lot of familiarity with a certain field, and it's like, oh, here's this context for this idea that is maybe might feel more abstract. And I always appreciate that.
I can help you with that. I'm still learning as well, and I most of the times I tend to search for the root cause or root level or the metaphysical aspect or ontological. So as you do in your personal studies, I also
Yeah.
try to do that, and I can provide you these concepts. My only concern is,
Well,
if you really try to understand these things, it's good, but they take a long time to learn. And my concern is to get you a job in programming as a software developer as soon as possible.
oh
So
yeah,
I don't really care if you know Markov's chains at all, at least for now.
I appreciate that. I think it's interesting how talking about these fundamentals connects on these very, very interesting concepts. Like, one of the things I think of is in science, in quantum physics, there's this very important concept of information. Information itself is a fundamental thing, especially in like astrophysics when you're talking about black holes. The loss and the creation of information is such an important physical concept, they have to account for it. And like you can't just create information out of nothing. And so thinking about it, you can think of the organization of reality as like a total information organization where there's something about the way that the organization of that information works that we have to organize it ourselves, and we call that consciousness. But we're organizing it out of a field that may have infinity like embedded in it. So you could have infinite information in every single aspect of existence in a sense, but then it's just a matter of how you're accessing it, and your ability to understand that infinity in it would be the same as your ability to comprehend the informational structure of that infinity. And you approach it by doing these things, by making these associations that we're talking about in this database structure. That approaches whatever would be the total understanding of here's all the information that can possibly exist and how it all relates to each other, which I think that's something where scientifically this would sound like pseudoscience to a lot of people, but as a thought, it's interesting to think maybe that's what collapsing the wave function is in quantum physics, is that you have this wave that is this composite of all of these possibilities where they say, hey, if you're doing the dual slit experiment and you shine a laser through these two slits, if you don't look at it and you get the wave-like nature of it rather than the point-like nature that comes from trying to observe it, if you don't look at it and you get the wave-like nature of it, they say it's the same mathematically to say that the photon went through the right slit as it went through the left slit, as it went through both slits. And in fact, that it takes every combination of paths, which I think is the Feynman path integral or something like that. So I can't remember for sure. I know that's what he was dealing with, was these paths. But it takes all of these possible paths. And so until you observe the outcome, you can say that the state was totally unknowable, and you can say it's a complete composite of all possible states. And so on that level, it's like we take that composite and we find a way to understand it, but there is some informational organization to it, and that's what we call reality or existence in my mind.
Yes, I remember someone argued that both occur in different realities. One is occurring in a reality where there was no observation, and the other one is occurring in a reality where there is. But I don't know too much about this.
What I just described, if you want to know a little more about that, is called the Copenhagen interpretation of quantum physics. And there's this channel that just did a really good video on this called PBS Spacetime. If you want to check them out. So it's the most recent video that he did. That'll get you there.
Yes.
Yeah, and if you click on it, let's see. Oh yeah, Heisenberg made a discovery in 1925. It was that video. So if you go to videos, the most recent one, that video, Heisenberg made a discovery that we still can't explain. Watch that one. You'll find it really interesting because he talks about how this sort of logic was, how they arrived upon it. And that one interpretation of things was that unless you are measuring something, there isn't anything there. There is no reality separate from the measurement of it. And so we could say that consciousness is constantly measuring reality, but it's just an interpretation that lets the math work. And certain people like Schrodinger really didn't like that. And you've probably heard of his Schrodinger's cat, right? Where he's like, there's a cat in a box and there's a 50% chance it's alive. There's a 50% chance it's dead until you open the box. You don't know which state it's in. Well, he gave that example to highlight the absurdity of that idea, but it was a really good explanation of what needed to be thought about and what needed to be focused on as a possibility. But he chose a cat and this concept of a dead cat being both alive and dead to say, this is absurd. It can't be this. It's really funny.
It's just no sense. I never understood this Schrodinger cat. I don't get it.
Oh, Schrodinger's cat. Well, so the experiment is that what you do is you take a particle with a half-life that is like, I don't know, 10 seconds or something like that. And it decays constantly. And you know that every 10 seconds, there's a 50% chance, an exactly 50% chance that it will decay. And if it does decay, it will release a poison that kills the cat. And if it doesn't decay, the cat will not die. And so you can look at this box and you can know at that moment of decay that there's a 50% chance the cat is alive and there's a 50% chance the cat is dead. But until you open the box to see, there's no way to say. So in the experiment, though, because the chance is exactly 50%, the cat is both alive and dead in that moment before you observe it, because there's no probabilistic weight in one way or the other. There's no more probability that the cat is alive than there is probability the cat is dead. It's equal probability between both. And so to you as the observer, you have to see it before you can know. And so it's demonstration of the idea that the observation is the reality in that sense. When you observe, then you know the cat is dead or you know the cat is alive.
They are talking about the neutral point between these two states. So the equilibrium can be labeled as neutrality.
Yeah, and that's a theme that comes up in physics a lot. Like you'll see the concept of a perfect sphere sitting on top of a perfect hill that has the same essentially it has a slope in all directions, and so there's no reason for it to go in one way or another way. And that ties into something called the principle of least action, which is that the ball has to go down the path that's the easiest for it. But if you find that perfect point of balance, then it causes problems for something called determinism, which is the idea that a physical system must always play out following a precise set of physical actions. Like you talked about going back in the code and looking at the series of things that led to the output that was like incorrect. What was that called again? You had a name for it. Like if it came up with a bunch of error codes, then you go back to the code that led to it. Traceback. Yeah, stack track. And so it's like it's a bit like that, where it's like there's a cause for everything. And so if you just can sit this ball on this perfect hill and there's no reason for it to go this way or this way or this way or this way, then it erases all of that information. There is no causality, there's no structure leading up to the moment. It just goes down a path just because and for no real reason, which is what would, in their mind, allow for free will to exist.
This video, there were two guys talking and arguing with each other, but not random guys. They were really smart guys for their times, and they were talking exactly and precisely about the terms determinism. So this guy Markov, they were, I don't remember exactly, but they were trying to figure out if determinism was true or not, and the free will problem, because usually determinism and free will come together in these topics. I don't remember which one of them was trying to revoke or to prove that the determinism was true, but they talk about this. At the end of the day, at least for language prediction, there is no determinism, but there is enough predictability. That was the conclusion. That's why we can type some text and the algorithm most likely is going to predict what the word is about that we are trying to write, because it's predictable enough, but it's not deterministic.
And there's something interesting too, which is that there is a determinism in the idea that the algorithm will evolve. Information will be processed more efficiently over time. And so you do see that in the world, that things grow and that they change because they are iterating on what is already known. And there's no place that you can really arrive at where there isn't something else to know. There's no other way to grow until you could create that algorithm that I was indicating earlier, which would be just that convergence of all possible information that existence might be exhibiting as like a singularity, essentially. That would be the maximal organization of information relative to infinity, like the fabric of whatever that is. Like, have you heard of uncountable infinities? That's a really interesting concept.
Is it related to different kind of infinities? For example, the infinity for natural numbers, the infinity for irrational numbers, they are different, even though they are infinities.
Well, it's hard to explain because I haven't looked at the concept in a little while, but I can give you a rough sense of like the sort of gratification that comes from understanding it. It would be like you define a certain set of numbers and it has a pattern to it. But because of the way that pattern is defined, it's always approaching an infinity of another number set, but they can only ever approach each other. They can't really ever cross. And so there's a lot of logic behind it that when you understand it, it's sort of like you go, oh wow, I can see how this infinite number set cannot contain this infinite number set. They're both infinite, but they won't cross.
Yes,
And you'd think
it's the different infinities theory that was proved mathematic. I forgot the name of the guy, but he proved that in natural numbers, for example, they are infinity. But there is numbers between the natural, rational. I mentioned natural, but it's rational. Rational numbers, they are infinity, but between them, there is fractions, for example. And these fractions, they are also infinity, but they don't overlap, never. It's exactly what you are mentioning, because they are different categories. So they never overlap, even though they are infinity.
Yeah, that's a very interesting perspective on this, because I would say that would be a companion to the exact concept that I'm talking about, because the concept I'm talking about would be whole integer number sets, where you're only using like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And so on. But there's a way of these integer number sets. You can have two integer number sets that are always approaching each other in a sense, but are never overlapping. It's a really hard concept, like, to wrap my mind around. And like I got it a couple of years ago, and I was like, oh, amazing, right? So it's definitely worth thinking about, but I just can't quite remember like how those pieces went together or what it was. I mean, I guess I could just give it a quick look and see, because it would maybe take me a little while to refresh my memory. But what you're saying is interesting too, because it's the fractional version of that, which I often think of, because you can reframe the entire set of numbers so that it is all it's all dependent on one. All math is dependent on one, in the sense that 2 is 2 ones, 3 is 3 ones. Fractions, in a sense, are all just fractions of one. 1 divided by 10, 1 divided by 2, 1 divided by a million. So it's really just a question of, you're saying, are you using one kind of as this building block that repeats, that you iterate on by, you have 1, 1, 1, 1, 1, and that becomes these like Legos for this bigger picture? Or is what you're saying that there's just one block, there's just one thing, and you're breaking it down like a picture that you're drawing lines in, and it brings out all of these different qualities and structures? So you can look at the whole system set as structured, and you break down those structures out of this one thing, or you can look at it as there's just these tiny little building blocks, and you build them up into structures. And so that's the side, building up into structures is more where I was coming from, and breaking down a single structure is more where the logic that you're talking about is coming from. Like, you can break down structure infinitely, and it won't ever arrive back at the main structure itself, would sort of be the idea there. Even if things are holographic, like, at least that's my way of seeing that.
I will need to study it more, because I'm not so advanced in this subject. But you can, I will see and watch those videos that you sent me, and later on we can talk more about this. For now,
yeah, and
I
they're
will
called,
need to go.
oh, great. And they're called uncountable sets. That's what they're called.
Uncountable sets. Okay, I will search about it.
Yeah, thank
I
you.
like
Thank you for.
Uncountable sets. Okay, noted.
Yeah, you can look at that in Wikipedia. Super interesting. But it's definitely been good time chatting. Thanks for like that really excellent view on the world of
Thank you. I
programming.
appreciate your time. Hope that some of my things that I have presented that doesn't overwhelm you, because it was a lot of stuff. You don't need to memorize everything for now. It's just an exposition, just for you to be aware of this stuff.
Oh,
and you are going to have plenty of opportunities to really go deeper and deeper on then later on, no problem.
It was very
For now-
clarifying. Yeah.
Good, thank you. For now, I will take some pause and eat something, and later on I will keep working on this stuff that I was doing because I need to deliver this on Monday, so I don't have any options. And yeah, let me see what else. Okay, for now, keep reading the clean code book and also the Head First Java. They are really important and they are going to be demanded on the interviews. If you want to have a broader, really broader perspective of the entirety of computer science, read a book called Category Theory for Programmers. I sent you the link in your LinkedIn account.
Oh, okay.
It's free, so you can read it whenever you want. It's not a easy reading, but it's worthy, and it's not something that you are going to get in the first reading because it's really dense, but it will give you a really landscape of programming in any human programming human language, because it's out there. Category theory for programming.
Right.
So usually category theory is from mathematics, and it's I think almost 1 year of study, and it's not easy.
Wow.
But this book is specifically for programmers, so it's more distilled for us, so it's easier to understand. And treat this book as a background reading. I'm not asking you to finish it in 1 year. So treat it as a background stuff that you are doing sometimes. Don't care too much about it. Focus mainly in the clean code and Head First Java.
Okay, I will definitely work on those. Thank you, Robson.
Thank you. Bye-bye.
Take care. I really appreciate it.
Take care.